So today I'll be taking 10 likely JAMB 2026 question and answers that are 99% guaranteed to come out. Alright, so these questions, starting with this one, have been repeated constantly by the JAMB examinations for the past 2, 3, 4, even 5 years ago. So they are most likely to come out, and I'll be taking this first 5 in this video and another 5 in the part 2 of this video. Alright, so we'll do more like this so that the higher your chances of seeing these questions in the examination. So question 1, it says, what volume of oxygen is produced at s.t.p when a current of 5 ampere, that is stands for ampere, is passed through acidified water for 193 seconds? Taking bracket F, which stands for Faraday constant, is 96,500 coulomb per mole, and we have the molar volume constant given as 22.4 dm cube. So A, 0.056 dm cube, B, 0.224 dm cube, C, 0.56 dm cube, D, 2.24 dm cube, E, 22.4 dm cube. Right, so I'll be giving you one straight formula that you can use to solve this question. The formula is that, let's go the solution. So it's one formula you can use to solve questions of this nature. The formula is that V, which stands for volume, is equals to GMV, gas molar volume, which I gave us as 22.4, is a constant, times I, which stands for current, times T, which stands for time, all divided by Faraday's constant F, times E minus. Now E minus stands for total electron transferred. Alright, that's E minus, which in most cases is the charge of the element being liberated. Now let's plug in our values. They asked us to find volume in dm cube, right? GMV is 22.4, that was given. Alright, current was given as 5, time was given as 103 seconds, Faraday's constant 96,500. As for your total electron transferred, oxygen is a gas represented as O2. Alright, 1 mole of molecular oxygen will give us 2 moles of atomic oxygen. Yes, and 1 mole of atomic oxygen actually will release 2 electrons to become an ion, O2 minus. So in that case, anyways, oxygen gas has 2 moles, so that becomes 2 moles for each mole of oxygen as released. So I have a total of 4 there. That's 2 plus 2, which we work 4. Now we're going to calculate this. So we have 22.4 times 22.4 multiplied by 5, that's current, 193, which is time, 96,500 Faraday's constant, times 4. So our answer is 0.056. Alright, so the answer here is 0.056 dm cube, which matches perfectly with option A. Question 2. A compound contains 40% C represents carbon, 6.7% H is hydrogen, and 53.3% O, oxygen. Now, by mass, so these are representation by mass. Its empirical formula is A, CH2O, CHO, C2H4O2, CCH12O6, and CHO. Now, empirical formula of a compound is that simplest formula of the compound, meaning that the numbers which are here, yes, the numbers below the element, subscripts of the element, they must be in their simplest form. Alright, obviously, if you observe C2H4O2, I can divide all through by 2 to obtain CH2O. I can divide all through by 6 here, yes, because that's common, to obtain CCH12O6. So, by knowing what the empirical formula is, I've eliminated option C and D. We have option A, B, and E left. Okay, I think, sorry, that's an error. Yes, CHO3. Alright, so let's do solution. So let's be sure of our answer. Alright, they said 40% carbon C is 40%. Hydrogen is 6.7%. Oxygen is 53.3%. The question said these are representations by mass. I can assume that the total mass of this compound was 100. Alright. Carbon takes 40 grams. Hydrogen takes 6.7 grams. Oxygen 53.3 grams. To find the mole fraction, I'm going to divide by the molar mass of each of these elements. Carbon is 12, so I'm going to divide 40 by 12. Hydrogen is 1 and oxygen is 16. So if you do this, 40 divided by 12, we have 40 divided by 12, that's 3.33. So this is 3.33, that's mole fraction. Here is 6.7, then because anything divided by 1 is a number, 52.3 divided by 16 gives 3.33. 3.33. Now these are mole fractions. Why? Because we have mass divided by molar mass to give us a number of moles. So this is mole fraction of carbon, hydrogen, oxygen. In order to get the empirical formula, I'm going to divide by smallest value. Smallest value is 3.33. Right, so there again, smallest value is 2.33 and 2.33. So this will give us 1, this will give us 2, and this 1. So 1 goes to hydrogen, that's C, left as C. 2 goes to hydrogen, 2, and oxygen 1. So CH2 is our empirical formula. Option A. 3. A gas occupies 300 cm cube at 1 atm and 27 degrees Celsius. What is its volume at 2 atm and 127 degrees Celsius? So if you observe, we are dealing with volume, pressure, and temperature, and what comes to our mind is general gas equation. So let's write solution. So the solution. Now, the formula for the general gas equation is that P1 initial pressure, V1 initial volume divided by T1 initial temperature in Kelvin, alright, is equals to P2, V2, and T2. Now, the units of pressure and volume do not really matter in the sense that, let's say for example, in this case, we're giving pressure in cm. We're giving pressure in ATM. Now, if we do ask to find final pressure, we're going to get an answer in ATM, which you can convert to other units of pressure like mmHg, torr, and likes of them. But our temperature must always be in what? In Kelvin. Alright, so let's plug in our values. Initial pressure was 1. Initial volume was 300. Initial temperature was 27. Now, to convert from T degree Kelvin is equals to T Kelvin, T Kelvin. Kelvin is an absolute temperature and therefore should not be represented in degrees. So it should represent in T degrees Celsius plus 273. Alright, so get Kelvin, we add 273 to the value in Celsius. 27 plus 273. Right, so this should be equals to P2, that's the second pressure, which was given as 2, times they asked us what is the final volume. V2 127 plus 273. Alright, so we can write this as 300 over this and this. That gives us 300 again. This should be equals to 2V2 over 127 plus 273. We're going to get 127 400 and get V2. So V2 cross multiplying will be equals to 300 times 400 over 300 times 2. Alright, so this will cancel out this. Here will cancel out this. We have V2 is equivalent to 200 right now in cm cube. Option B. For 25 cm cube of 0.1 molar, that's concentration dm cube, HCl neutralizes 20 cm cube of NOH, sodium hydroxide, hydrochloric acid solution. Alright, the concentration of NOH. Now, when I mention sodium hydroxide and hydrochloric acid, this is a base, this is an acid. Neutralization reaction. Now, for a neutralization reaction, I'm going to use what? The neutralization equation. So let's go solution. What do we have now? The neutralization equation is given as Ca, concentration of acid, times Va, concentration of acid, volume of acid, divided by Cb, which is concentration of base, times volume of base, is equals to Na over Nb. Now, from what they give us in the question, CAV and CBVB are already conspicuous. All right, we know the values from looking at the question. But what about NA and NB? In order to get NA and NB for neutralization equation, we must first write out what the balanced equation. Now, for this equation, it becomes NOOH plus HCl. All right. Generally, acid and bases react to give salt and water. Salt here is NaCl, which is common salt, sodium chloride, plus H2O, that's water. This is a must product for any neutralization reaction. All right. If you look at the equation, you're going to notice that it's already balanced. We have 1 mole of sodium, oxygen, hydrogen, and chlorine. So let's plug in our values. Concentration of acid was given as 0.1. 0.1 times the volume of acid, which was given as 25. Concentration of base was given as 20. They asked us for the concentration of NOH, so that's Cb. Now this will be equals to number of moles is 1 over 1. Now if I make Cb to a formula, we have that Cb, which is concentration of the base, will be equals to 0.1, all right, times 25 all divided by 20. So if you impute that, all divided by 20, so we have 0.1 times 25, this divided by 20, we're going to have 0.125, that's 0.125 molar, which is 0.125 mole per dm cube as concentration. That's option B. Question: 0.46 gram of ethanol raised the temperature of 50 gram of water by 14.3 Kelvin. Calculate the combustion of ethanol. Specific capacity of water is 4.2 joule per gram. The molar mass of ethanol is 46 gram per mole. Now, so the full question was supposed to be calculate the heat of combustion of ethanol. Now, the heat of combustion of ethanol is the amount of heat that will be released when 1 mole of ethanol is burnt. How are we going to find out? I'm going to find the amount of heat that was released when 0.46 gram of ethanol was combusted. How? H, which is amount of heat liberated, is equals to mass times C, present specific capacity, times change in temperature. Now, I'm going to find the amount of heat that 0.46 gram released. Since it was able to act on water, can I say that the heat released was equals to 50 gram of water times 4.2, and then change in temperature was given as 14.3. So if you calculate this, we have 50 times 4.2 times 14.3. This is giving us 3003. So this is 3003 joules when 0.46 gram was consumed. So alright, if 0.46 gram liberates 3003 joules, then 46 gram will liberate X. How much heat will 46 gram, which is 1 mole, liberate X? So cross multiply X, we are equivalent to 46 times 3003 divided by 0.46. Alright, so let's impute this. We have 46 times 3003 divided by 0.46. That's 2, alright, joules. Now I can convert this is joule per mole. I can convert these joules to kilojoules by dividing 1000, because our options, the units are in kilojoules. So if I divide by 1000, I'm going to obtain that divided by 1000 is giving us 300.300 kilojoule per mole. Now our answer here is 300.3 kilojoule per mole, but we have A and C having signs before them. Here is plus 300 kilojoule per mole and here is negative 200 kilojoule per mole. Now most students you'll be tempted to pick option A. Why? Because here is positive, right? But obviously option A is what? Wrong. Why? Because heat of combustion, heat is always liberated. Alright, it's an exothermic reaction, so meaning that the heat of combustion or heat liberated is negative. since the system loses heat, so the system loses heat, the answer becomes what? Negative. So we'll have minus 300 kilojoule per mole. Alright, make sure to like and subscribe this video if you watch the end, and I'll see you later for the rest 5 questions that we're going to answer. Thank you.